start talking in 10 seconds. Hello, everyone. Welcome Henry O'Brien, a software engineer at Atlassian, in giving his talk on Kotlin because Java is so last year. Henry, you may take it away now.
Thanks. Welcome everyone of the internet. Hope you're all ready to cotton on to Kotlin, or maybe I should say Kotlin on. So I am Henry. You may have seen me on Slack as Hob. I graduated from UQ last year and I'm currently working at Atlassian where I use Kotlin pretty much every day. So you guys, the people who I cannot see, hopefully you may know a little bit about Java. If you don't, that's no problem at all. But I will be showing a few snippets of Java code. So if you don't understand those, feel free to ask any questions in the comments. But the main thing is that you are here to learn about the beautiful language of Kotlin. And by the end of the talk, hopefully you'll know when you can use Kotlin, maybe a little bit of Kotlin's cool language features, and maybe this will be you. There will be a little bit of Java bashing during this talk. Java is a great language, but Kotlin really is the superior of the two. So I've mentioned Kotlin. By now you are probably aware that Kotlin is a language. It's a very beautiful language, and I have a photo just to demonstrate the beauty. This is obviously not the Kotlin I'm talking about. This is the island Kotlin, which as a fun fact was what the language was named after. This is the language Kotlin. This is your hello world function written in Kotlin. We will see some more interesting code. So don't worry if you're like, oh, I came here and all I'm seeing is hello world. We will get into more cool Kotlin. But before we go any further, let's recap some Java basics because as you'll find out in a moment, Kotlin and Java are very closely related. So when we want to write Java code, we write out our Java files, and we then compile that and we get our class files and we run it on the magical thing called the Java virtual machine. That magical thing essentially loads in your class files and then uses a just-in-time compiler or sometimes an interpreter to convert those class files into an operating system instruction set and then executes that instruction set. So basically, you can run Java anywhere as long as you have that magical thing, the JVM. Now, people over the years have seen the JVM and gone, wow, this is really cool, unlike the language itself. So let's use the JVM as the basis for some other languages. And out of that, we got Groovy, which we do not talk about, and far better languages such as Scala, and as I'm talking about today, Kotlin. So Kotlin was born when some developers at JetBrains decided that the languages that were already out there were just not good enough for them. Java, for example, is a very verbose language, and Scala, which was becoming the big thing at the time, is kind of slow to compile. And JetBrains were not happy about that, so they decided, let's create our own language. And they created Kotlin. Kotlin runs on the JVM, and because of that, it is fully interoperable with Java. So you can write Kotlin code and use existing Java code, or you could go the other way around, not that you'd probably really want to. But Kotlin is a lot more concise than Java and a lot safer than Java code. So where can someone use Kotlin? And when people say the word Kotlin, a lot of people go, oh, that's the Android thing. I'm not a mobile developer, so Kotlin is not for me. Yes, Kotlin is very popular for Android development, but it is not the only use case. There is a heap of support for Kotlin in the Android libraries, and Google, as of last year, now recommends Kotlin over Java for Android development. But Kotlin can also be used for server-side work, which is mainly what I use Kotlin for. So Kotlin is supported in Spring if you are one of those people who unfortunately has to use Spring, or maybe not so unfortunately. There are also a bunch of web frameworks for Kotlin out there for writing cool web applications. Now you may be going, okay, I'm not really a backend developer. I like my front-end stuff. I like writing my JavaScript. Kotlin is not for me, but actually you'd be wrong. Kotlin can actually compile down into JavaScript, and therefore can be used for both server-side and client-side applications. There is support for many of your JavaScript libraries. So if you want to use jQuery, you can use that. If you want to use React, you can use that. And you can essentially be writing client-side code with Kotlin. And then maybe you're one of those rare people who likes to do a lot of embedded work, and you're like, okay, well, this is all reliant on the JVM. That's never going to work on an embedded system. Well, fortunately for you, there is this new Kotlin compiler, Kotlin native, which will compile down into native binaries. So no JVM, but it allows you to essentially have executables that runs on various platforms. You can write iOS applications with Kotlin, Mac applications, Windows applications, Linux. And Kotlin native is fully interoperable with C libraries and Apple frameworks. So while it is still a fairly new thing, it is very powerful, and I'm sure will become quite powerful in the future. But let us stop talking about Kotlin and actually write some Kotlin. But before I do that, let's go through these comments. Are they going to get sued by Oracle now? Who knows? Maybe they will, but they haven't yet. Can you tell us about Kotlin native through LLVM? How is the support? Do normal libraries work? So yeah, while Kotlin native is certainly very new and the support is still growing, yes, you can certainly use existing libraries written in C, C++, and your Apple languages. Okay, on to some Kotlin writing. And to start with, let me just make you aware of the syntax of Kotlin. It is slightly different to Java, but there are also a lot of similarities that you will notice. So to start with, here we have a function declaration. We declare functions in Kotlin with the fun keyword. We give it a name like Java. And you'll notice that the typing of parameters is around the other way to what you're probably used to in Java. So you have the name of the parameter and then the type of the parameter. And then your return type actually goes at the end of the function signature before the body of the function. Kotlin has the concept of both variables and values. So variables being mutable, values being immutable. Kotlin will work out types for you. So if you say var name2 equals this string, it will work out that that is a string without you having to specify that it is a string. Of course, you can still specify that if you want to for readability reasons. So here I have a little bit of not Kotlin code. This is Java code. It is a small little method that takes a string and splits the string into everything before the first occurrence of the separator parameter and everything after that first occurrence of the separator. So if you give it a run with hello world and the space as input, you will see that it prints out hello and it prints out world. And to do this, it uses a class called string pair. String pair is very simple. It is literally just storing two strings. And you'll notice there's a constructor, there's getters, and there's setters. Now you may look at this and go, this is very simple already. Can Kotlin really make this better? And the answer is, in fact, yes. So here is the function signature in Kotlin. Currently, you will notice that string pair does not exist. Now, what I could do is I could import string pair from the Java code because, as I said before, Kotlin is fully interoperable with Java. Alternatively, I could just use Kotlin's inbuilt pair class, but we are going to reinvent the wheel a little bit here just to demonstrate how great Kotlin can be. So what I'm going to do, I'm going to go to the Java version of string pair, and I'm just going to copy this. And IntelliJ is very smart. And if I copy Java code into a Kotlin file, it'll ask me, do you want to convert it to Kotlin? And I click yes, and it converts it to one line of code. So classes in Kotlin are really a lot simpler. So let me just explain the syntax for classes. The primary constructor for Kotlin classes is all located in the class header. So you'll give the class a name, and then everything after that is what we call the primary constructor. That primary constructor can only contain parameters. It can't contain a body. But what it will do is it'll generate fields for every var or val you have in those parameters. And what it'll even do for you is it'll generate an implicit getter for each var and val, and also a setter for each var. So what I mean is a getter for everything and a setter for everything that is mutable. So in this case, you'll notice there is no more constructor written. There are no more getters and setters for first and second. There is just one line of code. And what we will do now is we will copy in the rest of that code. So for the halve method, we will convert that to Kotlin code. We will fix this because IntelliJ thinks I want to use the Java string pair, which I do not, because I have written this much more nicely in Kotlin now. And you will see that, well, it's actually fairly similar, almost identical even. But I should be able to run that now and should give me the same output. It does not, because what did I call it? First and second. Okay. Let's run that again, and hopefully it'll give us what we want. There we go. Gives us hello world. And you may be thinking he's done. He hasn't actually done much. Kotlin's actually fairly boring. But I'm not done. But before I keep on going, let's just quickly talk about classes a little bit more. You can write your own getters and setters if you want to, and you can declare more fields for your classes and other constructors. That all goes inside the class body, not inside the header anymore. Inheritance is a real interesting thing in Kotlin because in Kotlin, classes by default are final. So you cannot inherit from classes by default. To make something inheritable, you do have to mark it as open. Some people hate it. Some people love it because it actually makes you think about what should be inheritable and what shouldn't be. Okay. let's make the Java code a bit better before we make the Kotlin code even better. And in this case, perhaps the space separator is being passed in a lot, and we don't really have to be passing it in all the time. So what we could do is we could overload this method so that it takes a string, doesn't take the separator, and calls the original halve method with the string and the space as the separator. And I should return that. So now what I should be able to do is run this without the space, and it should work fine. Cool. I don't actually have to overload that method if I wanted to do the same thing in Kotlin. Like Python and several other languages, you do have the concept of default parameters in Kotlin. So what I can say is separator has a default value of space. And now I can keep on passing in the separator if I want to, or I can just get rid of it and it will use space. And that continues to work as I expect. So here's another example of using default parameters. You'll also notice here that Kotlin functions can be one-lined if the only operation they're doing is returning, like so. Okay, to-dos are something that is a little bit more interesting in Kotlin than in a lot of other languages. So to demonstrate this as an example, let's say I want to make an addition to this code, starting with the Java code. You'll notice that there is a case where this code will break. If I just remove that space there, so there is no occurrence of the separator at all, I will run this and get a nice big red error. String index out of bounds. And how can I fix that? Well, maybe I should explicitly handle the case where the separator is not in the string, or in different terms, when string.indexOf returns a value less than 0. So if separator index is less than 0, let's say I don't really know how to handle this case. So I'm just going to say to do handle this later. And I'm going to put the return statement inside an else block. Not that I really have to, but it is going to demonstrate something in a second. And you will notice I get the squiggly underline that comes with a compiler error. It's saying missing return statement because this if block does not have a return statement in it. And it is expecting a string pair to be returned. So maybe what I'd want to do is just return null. But in Kotlin, there is actually a nicer way of handling that. So what I can do is I can say if separator index is less than 0, instead of writing my to-do as a comment, Kotlin actually has a to-do function. Now I might want to say handle this case later, and chuck that inside an else. This actually compiles fine, because what the to-do function will do is when I run this and I hit that to-do like this, instead of doing some sort of error that doesn't make sense to me, it'll just say this isn't implemented, and it'll say to me handle this case later because that is what I've written. So that's a very small thing, but also a very useful thing in cases like these. Now let's say me returning null is actually what I want to do here. So the Java code is correct. And those of you who have seen Kotlin before may know where I'm going with this. I'm just going to run the Java code here. I get a null pointer exception. Why is that? Well, I am returning null, and then I'm trying to call get first and get second on null. Obviously, that is not allowed. Kotlin, and one of the most famous things about Kotlin is that it does not have null pointer exceptions, usually. Unless you have decided yourself that you want to throw null pointer exceptions, they should not occur. And that is because in Kotlin, types are explicitly nullable or non-nullable. So in this example here, you will see I have x. X is a string. This is a non-nullable string. So if I try to assign null to x, it will not compile. On the other hand, y is a nullable string. It's got a little question mark here, which represents nullability. And so I will be able to assign that null to y. So back to this code, let's say I now want to return null. And it's saying this is bad because I'm returning a string pair, not a nullable string pair. So what I have to do here is I have to mark that as nullable. Now we're getting some more compiler errors down here under our little operation here. And that is because when you have a nullable type in Kotlin, the only things it will let you do are null-safe operations. So a null-safe operation is represented by a question mark before your dot. And what that will do is if the thing you're operating on is null, it'll just return null instead of throwing a null pointer exception. Now, there may be some cases where you actually do want a null pointer exception to be thrown. You can use the double exclamation mark there to throw a null pointer exception if it is null. So in this bottom line here, if I pass in null as s, this bottom line will throw a null pointer exception for us. But using the double exclamation mark operator does require you to actually think about what you're doing, because it is very easy to scatter them everywhere to get things to compile. But if you do it wrong, those null pointer exceptions you got rid of by using Kotlin will probably return. So what I will do now is I will make these null safe calls, and you'll notice when I run this with something that is going to return null, it'll just print null and null because these null safe calls will evaluate to null because halved is null. Okay, moving on. Let's talk briefly about data classes, which you may have come across in other languages, but probably not Java. You will notice before I had this written as just this, print halved, and when I ran it, it gave me this ugly thing. Those of you who have done a bit of Java before probably know this is because I have not written a toString for my string pair class. Now I could go out and write it, but really all I have to do is mark this class as a data class, and Kotlin will go, oh, this person wants a data class. Let's be nice and add a toString method. Let's also add an equals and a hash code. And while we're at it, let's add a copy method. So what I can do now is run it, and it will give me this nice readable form for my output. Okay, and we're nearly done with making this very Kotlin-y, but one other thing we can do is we can convert this to an extension function. What is an extension function, you might ask? Well, you've noticed that I've written this Java code in a class called string-util. Everyone's written a string-util before, I'm sure. But maybe we want this halve method to actually just be a method inside string. Now, obviously in Java, we can't do that because string is hidden far, far away in places we cannot edit. But in Kotlin, we can use what's called an extension function to treat this halve method as if it were a method inside the string class. And to write that, I just write this as function string dot halve. I don't need this string parameter anymore because now the string that I'm operating on is this being the instance of the string class. And down here, instead of writing it as halve hello world, I write it as the string hello world dot halve, like that. Here's another example. We have a double method for integers, and we can call it as so. So instead of double x, we write x dot double. By now, you may be aware that Kotlin does not actually have the concept of primitive types like Java. So you have ints and booleans and all that, which can be treated as any other class you have. Yes, Java has that too, but in Kotlin, there is no more messing around with primitive types. Now, before we finish up on extension functions, just a warning for those of you who are like, oh, this is such a great thing, let's go out and use extension functions everywhere. They're very easy to overuse. So just be careful, and when you're writing an extension function, think, is this actually a good use of an extension function, or is there something better I can do? Okay, and this is pretty much perfect. We are getting a little warning here saying return should be lifted out of if. In Kotlin, ifs and many other things are not just a statement, they can also be treated as an expression. So what I can write here is return if this, and then just null and just string pair. Kotlin also does not have the new keyword. You can instantiate things just by writing the name of the class. And that is our much nicer string util method written in Kotlin. Let's go through these questions. I love how Kotlin calls everything fun. Yes, everything in Kotlin is fun. I wasn't expecting memes, but here we are. Yes, there are memes. And yes, Kotlin does have a cool file extension, KT. Yes, it does. Okay, we've got to talk about the annoying things about Kotlin. And there's really only one thing that I really don't like about Kotlin, and that is the lack of a static keyword. So Kotlin does have the concept of singletons, which can be created by replacing the class keyword with object. So you don't have to go out writing all your singletons from scratch. Kotlin will let you do that with one keyword. There is the concept of companion objects, which essentially replicate the behavior of static. But some days you just want a plain old static keyword. So that is the one thing I dislike about Kotlin. But on to some more cool stuff about Kotlin. Okay, let's change examples to this student example we have here. We've got a class here. It represents a student at a university. They've got an ID and a name, and each student also has enrollments. Now, in this student class, enrollments are actually stored in an external database, and so if we want those enrollments, we have to pull them from the database. So what I use is a pattern called lazy initialization. Essentially, what I'm doing is I'm delaying the initialization of our enrollments until it's first required, because calling those database methods that we need to get the data from the database is probably fairly computationally expensive, and perhaps we don't always need to get the enrollments of a student. So I'm only calling those expensive methods when I really need to. Before someone stops me, yes, this is a fairly silly example for lazy initialization, but just pretend this is all useful. Now in Kotlin, there is a concept called delegated properties, which makes lazy initialization, amongst many other things, a lot easier. Instead of writing out this null check and doing all that in a getter method, in Kotlin, I can basically do it in one line. So I have my student class in Kotlin here. I've also written an isValid method, which will come in handy when we do some stuff later. But for now, you can ignore it. How do we declare a lazy property in Kotlin? Literally like this. We say val, name of the field, by lazy. So if I want to declare the enrollments, say val enrollments by lazy. And then this here is a lambda function. That's what's going to get called when enrollments is actually needed. In that case, we say database dot, I don't even know what the method was called. Called get enrollments from DB. And it takes a student ID. Those of you who just saw the flash of my database code will have seen that it doesn't actually do any computationally intensive work. It is all a lie. Okay, and need to import that, like so. Okay, and now our enrollments is a lazy property. So this will only get initialized to what's in the database when enrollments is actually needed. What else can we use delegated properties for? We can make a field observable. So what I might want to do is add a new field to our student class called degree. So degree is going to be observable. Maybe I want to call some code when someone's degree changes. And in this case, it is not going to be able to infer the type. So degree is going to be, let's say it's a string, but I'm going to make it a nullable string because initially, let's say the student is not enrolled in the degree, and so we'll just represent it as null, as in no degree. And then we will write a little lambda. This is the logic that gets called when degree changes. This actually takes 3 parameters, those being the property itself, the old value of the property, and the new value of the property. And in this case, let's just print out what the new degree is. So we can print this. We can say student with ID has changed degree from old value to new value. And you will notice in Kotlin, you can just chuck variables into your string like this. What's actually happening in the background is it's creating a string builder for you and building up the string. But unlike Java, you don't actually have to write out that string builder yourself. You can just write it like this. And so now I have a little main method. We've got a student Joe, and Joe will initially set his degree to engineering, but then decide he's changed his degree to science. So if we run that and hope it compiles, there we go. It'll say student with ID 1, 2, 3, 4, 5, 6, 7, 8 has changed from null because initially he had no degree to engineering. and then he changes it again, so our listener will get called again. So that is observable. There are a few other delegated properties that are built in. For example, vetoable allows you to essentially perform an assertion on a value being assigned to some variable. And if that assertion fails, that value does not actually get assigned. You can also write your own delegated properties if you want to do that. But lazy and observable and vetoable and a couple others are all built in for you. Okay, Kotlin does have support for many functional constructs. If you want to do some cool stuff with higher order functions, I've already used lambdas. Kotlin functions are first class, so we can pass them around to other higher order functions. And there are plenty of utility functions built in that can operate on collections in Kotlin, fairly similar to Java streams. Now, this is nothing new. This is certainly not unique to Kotlin. There are plenty of languages that do similar things and plenty of languages that probably do it better. But there is one downside of using higher order functions everywhere. Higher order functions, in Kotlin at least, are quite expensive. In fact, when compiled, they're actually compiled down into anonymous classes. So a function type looks like this mess, very scary, lots of generics. But because this is each lambda function is getting compiled down into an anonymous class, there is a fairly significant overhead. And Kotlin has a way around that. And that is through inline functions. So what an inline function does is it will essentially take the body of that function, take the body of any lambda parameters that are called, and just inline them into your code. So this is for each, which operates on an iterable object. This is built into Kotlin. And down here, I've got a list, and I am printing each element of it. So instead of getting compiled down into a bunch of anonymous classes, what will actually happen is it'll get compiled down into something a lot nicer like this, because for each is an inline function. So it's essentially just inlined all that code into this nice little for loop. Now, if I was to look at some other code I've got here, let's actually just see how these higher order functions can be used in practice. I got a function here, remove invalid. Retain all is a higher order function. It takes a function, and in this case, it's checking is that course valid, and it's keeping every course in the list that I passed in that is valid and removing anything else. So is valid, as you saw before, is defined in the course class here. There's also one for the student class, which we haven't used yet. Down here, we've got filter. If you've done any functional programming before, you might already be aware of what filter does. It's very commonly used. And essentially, it'll just filter anything that meets this Boolean value that gets returned from the lambda that I've got written here. And if I was to write this, it'll tell me all these second year courses, because I'm filtering all the courses that have the first of the numbers as 2. And it gives us 2002 and 2010. Now, if I hover over filter here, you will see that this is an inline function. So what would actually happen here is this lambda here and the logic inside filter is actually going to get inlined for us. And finally, something very cool, but a little bit hacky. about Kotlin. Type erasure annoys us all. Let's say I wanted to write another function here. I also want to call it remove invalid, but instead of taking courses, I wanted to take students. And I will just say students dot retain all student is valid. And this does not like me at all. Even though these two signatures are different, because of type erasure, this is not going to compile. So if you've done any work with Java generics before, you'll know that generics are basically all treated as object. So this here is a mutable list of objects, or the equivalent in Kotlin, which is any. Now, there is a workaround for this in Kotlin. And you may be thinking the workaround is just renaming this to something apart from remove invalid. But I'm feeling really passionate about this name of my function here. I don't want to change either of these. So what I can actually do is mark this with the JVM name annotation. Maybe I'll call this remove invalid students. So inside the JVM, this is being treated as a function with the name remove invalid students. But in my code, I can still refer to this as remove invalid. And I should be able to call this code down here. You'll notice there are a couple of invalid students and courses in these lists here, and they get filtered out. So student with letters as their student ID is obviously not valid, so it gets filtered out. And also Kotlin 101 is very sadly not a real course because the course code is too long. So that also gets filtered out. And these two are both still called remove invalid, so I'm very happy. But this is being treated as remove invalid students in the JVM. And that is all the cool things about Kotlin that I have to talk about today. But there really are a lot of other cool things that I haven't talked about. So where do you go next to learn about all these other things and start using Kotlin? Now is a good time, by the way, to start asking any questions you have, and I will answer them in a minute or two. So if you want to learn Kotlin, there is this thing called Kotlin cones. Not actually sure how to pronounce that, but it's essentially just a series of small exercises that gets you using some of Kotlin's essential language features. So it's certainly not an introduction to programming thing, but it is an introduction to Kotlin thing. Once you know a bit about how to actually write Kotlin yourself, you'll then probably find yourself going into the documentation a bit. If you want to learn more about Kotlin native or Kotlin to JavaScript, there is documentation about that in these docs too. And if you're one of those Android developers who, for some reason, is still using Java, it's probably time to move over to Kotlin. And once you feel like you're on top of the language, try using Kotlin for your next project. And once that project is finished, share it with everyone on Slack so we can see it. And if you're really feeling adventurous, you could try using Kotlin native, even though it is still fairly new. Or you can keep on going with a Java project, but instead of finishing it in Java, finish it in Kotlin, because remember, Kotlin is fully interoperable with any Java code you've already got written. Don't do this for your 2002 assignments if you're a 2002 student, though. You probably will find bad things will happen. Keep on using Java for that. But that is the end of the talk. I will go through these questions. What are singletons? Singletons are basically something that gets instantiated but only once. So there is only one instance of that class everywhere. And it got answered in the next comment. Does Kotlin have a standard library? Yes, it does. Something's not a higher order function. Cool. Can you tell us about coroutines? I was afraid someone was going to ask about that. I have not used coroutines in Kotlin myself, but I have heard they are a fantastic alternative to threads. But I do not know enough about them to talk about them. How are you going? I am going very well, thank you. But if there are no other questions, I think that is it.
Right. Thank you so much, Henry, for giving this talk in UKCS. We loved having you. Obviously, I can't give you a mug at the moment, but I will present a virtual mug to you on the UKCS Slack. But yeah, that's it for today. We're gonna be running 2 events next week: a movie night and a talk on machine learning. So yeah, everyone tune in for those next week. And thanks again, Henry, for giving this talk.
Thank
Cool.
you.